Hi, welcome back to Moose and Chemistry. This is Nuclear Chemistry Uranium Decay Series number 2. So here's another possible pathway for uranium to decay from uranium to base lead. Alright, so now, wherever you see this A, that's talking about alpha decay or emission. A 4He nucleus or 4,2 alpha, which is called an alpha particle, is removed from the parent atom to change the element into a different element. We're going to use this formula here. A over Z, X yields A minus 4, Z minus 2, Y, plus the alpha particle right here. Now, A represents the AMU, okay? So that's the number of protons and neutrons in the nucleus of an atom. Z represents the atomic number, which is the number of protons in the nucleus of an atom. Y would represent our new element. And again, 4 over 2 He is our alpha particle. All right, so now let's go ahead and start this. So uranium-238 undergoes alpha decay, becomes thorium-234. So thorium-234 undergoes beta decay. Now, what is beta decay? Beta decay, guys, this is the B here, and beta decay is 0 minus 1e or 0 minus 1b. A neutron is converted into a proton, changing the element into another element, and releasing a beta particle. And we're going to use the equation A over Z, X yields A Z plus 1, Y plus our beta particle. Okay? Now, our A, again, represents our atomic mass number, which is the number of protons and neutrons in the nucleus of an atom, and the Z number is the atomic number, which represents the number of protons. And our Y would represent our brand new element. All right, so thorium-234 undergoes beta decay and becomes element number 91, which is protactinium, and it's called protactinium-234. Protactinium undergoes beta decay again and becomes uranium-234. Now, uranium-234 undergoes alpha decay and becomes thorium-230. Notice that thorium up here was 234 and thorium down here is 230. They're both thorium, but they're isotopes of each other. Okay? So let's go ahead and clean that up a bit. Now, thorium itself also will undergo alpha decay and become radium-226 or 226. Radium-226 undergoes alpha decay again, becomes radon-222. Radon-222 undergoes alpha decay, becomes polonium-218. Pretty fun, huh? You know, while we were doing these, we could actually be using these equations, but the video would be very, very long if I did. So you guys go ahead and practice using these two equations here, and it'll make a lot more sense. All right, now, polonium undergoes beta decay and becomes the element astatine. Astatine undergoes alpha decay and becomes bismuth-214. Bismuth-214 undergoes beta decay and becomes polonium-214. Now, polonium-214 will then undergo alpha decay and become lead-210. But lead-210 is still slightly radioactive. So lead-210 will undergo beta decay and become bismuth-210. Bismuth-210 will undergo alpha decay and become thallium-206. And let's see here. Now, thallium-206 will undergo beta decay and become lead-206, which is a stable form of lead and will not decay any further. Again, you can look at these half-life tables here. You look at each of these elements and its isotopes, and you can see how many years, minutes, seconds, or even days that these particular elements undergo for their decay. But when you reach 206, down here at the bottom, 82, lead, that's stable or endgame. In other words, we don't go any further than that. All right, well, that's it for this lesson. You guys be snarly, and we'll see you back here at Moosine Chemistry.